You're sitting at your desk. Your phone buzzes. It's just an email from your boss with the subject line, "Can we talk?" Your heart rate spikes. Your palms get sweaty. Your stomach tightens like you've just stepped off a cliff. Nothing in the room has changed. No one is in danger. But your body doesn't know that. Because as far as your nervous system is concerned, you're being hunted. That feeling, the one that floods you before a difficult conversation, before an exam, before a text that says, "We need to talk," is not a glitch. It's not anxiety malfunctioning for no reason. It's a 300,000-year-old survival system doing exactly what it was built to do. The only problem is that it was built for a world that no longer exists. For most of human history, the things that could kill you moved fast and had teeth. A rustle in tall grass could mean wind. It could also mean a leopard. Your ancestors who paused to calmly analyze the probability of each scenario didn't survive to pass on their genes. The ones who froze, scanned, and reacted instantly did. So evolution didn't select for accuracy. It selected for speed. This is the part most people get wrong about fear. They think it's about being right. It isn't. Fear evolved to be wrong as often as necessary, as long as it was never wrong in the one moment that mattered. A psychologist named Joseph LeDoux spent decades mapping exactly how this works inside the brain, and what he found reshaped how scientists understand emotion itself. Deep in your skull, beneath the part of your brain that handles language and logic, sits a small almond-shaped cluster of neurons called the amygdala. It doesn't think in words, it thinks in patterns: shape, motion, sound, shadow. When something matches a pattern your ancestors associated with danger, the amygdala doesn't wait for permission from the thinking part of your brain. It fires first and asks questions later. LeDoux discovered there are two pathways information takes when something threatening appears. One goes through the thalamus, straight to the amygdala. He called this the low road. It's fast, crude, and reactive. The other route goes through the cortex first, where the brain actually analyzes what it's looking at, before looping back to the amygdala. That's the high road. Slower, smarter, but slower. Here's the unsettling part. The low road can trigger a full fear response in your body before your conscious mind even knows what you're afraid of. Sweat, adrenaline, muscle tension, all of it dispatched in milliseconds before the rational part of your brain has finished processing the sentence in that email. You are not consciously choosing to panic. Your amygdala already decided. Your thinking brain is just catching up. Why does this matter today? Because almost nothing in modern life is actually trying to kill you, and yet your amygdala can't tell the difference between a predator and a deadline. A psychologist named Robert Sapolsky has spent much of his career studying this exact mismatch in primates, both human and otherwise. His research compared the stress responses of zebras being chased by lions to the stress responses of office workers facing a performance review. The zebra's stress hormones spike violently for the few minutes it's actually being hunted. Then, whether it survives or not, the chemical response resolves. It's over. Humans don't get that resolution. You can lie in bed at 2 a.m. with your heart pounding over a conversation that hasn't even happened yet. Your body floods itself with the same cortisol a zebra gets while being chased, except there's no lion. There's no chase. There's just a thought. And thoughts, to your amygdala, can look exactly like teeth. This is the central irony of human fear. The very thing that made your ancestors brilliant survivors, the ability to imagine future threats before they arrive, is the same thing now keeping you up at night over things that will never physically touch you. Think about the last time you felt genuinely afraid that wasn't about something happening right now. A bill, a diagnosis you're waiting on, a text you haven't sent yet. None of those are lions. None of those have claws. But your body responds as if they do, because your nervous system evolved in an environment where almost every threat was immediate and physical, and it never got the memo that the rules changed. There's a reason this matters more than it might seem. Researchers studying what's now called threat generalization have found that the brain doesn't just react to actual danger. It reacts to anything that resembles danger, even loosely. A 2004 study led by researcher Mauricio Delgado used brain imaging to show that the amygdala activates not just to direct threats, but to symbols and cues merely associated with potential punishment. Your brain doesn't need a lion. It just needs something that once, somewhere, correlated with one. This is why public speaking terrifies so many people more than actual physical danger does. Standing in front of a crowd has never killed anyone, but for hundreds of thousands of years, being watched intensely by a group often meant one thing: you'd done something wrong, and the group was deciding what to do about it. Social exclusion, in a small hunter-gatherer band, wasn't an inconvenience. It was often a death sentence. No tribe meant no shared food, no protection, no one to keep watch while you slept. So when your palms sweat before a presentation, that isn't an irrational glitch. It's an ancient alarm system, mistaking a conference room for a tribal council deciding your fate. Here's where it gets stranger. Your body can't always tell the difference between emotional pain and physical pain either. A researcher named Naomi Eisenberger ran brain scans on people experiencing social rejection and found that the same neural regions that light up during physical injury also activate during the sting of being excluded. Heartbreak isn't just a metaphor. To your nervous system, getting dumped and getting hurt are processed through overlapping circuitry. This means your fear of rejection, embarrassment, conflict, and disapproval isn't a personality flaw. It's not being too sensitive. It's hundreds of thousands of years of survival programming, still running in a body that no longer needs it the way it once did, but hasn't been told to stop. So what do you do with a fear response built for lions, now running your life over emails? You can't delete it. It's not a software bug you patch. It's hardwired through millions of years of selection pressure, and it's not going anywhere. But you can understand it, and understanding changes everything about how it feels. When your heart races before a hard conversation, that isn't proof something is wrong. It's proof your ancient alarm system is doing its one job: treating uncertainty as danger just in case. The amygdala isn't trying to ruin your life. It's trying to keep you alive, using the only tool it has, which is panic first, ask questions later. The next time you feel that tightening in your chest before opening an email, or that spike of dread before a difficult call, you're not broken. You're not weak. You're a few 100,000 years of evolution, compressed into a body sitting at a desk, reacting to a deadline as if it were a predator in the grass. Your ancestors who felt that exact tightness, who treated every rustle as a possible threat, are the reason you exist at all. The ones who didn't feel it, who stayed calm when they should have run, didn't get the chance to have descendants. So that racing heart isn't your enemy. It's an inheritance. It's proof that somewhere behind you, in a lineage stretching back further than memory, someone's fear kept them alive long enough to pass it on to you. Tonight, when your phone buzzes and your stomach drops before you've even read the message, remember what's actually happening. You're not overreacting to an email. You're being hunted by a lion that's been extinct for 30,000 years, and your body still hasn't gotten the message that the danger passed. Thank you for watching, and I will see you in the next video. If you find this video interesting, please consider subscribing for more content like this.